Good morning, everybody. I think everybody is awake after coffee break. My name is Kula, and I'm a Jordanian scientist in Ghana. So we are going to shift gears from neurons to talk about stem cell research. And the idea behind the talk comes from the fact that I'm in a committee in Jordan that was put together to formulate some guidelines for stem cell research. Because for the last 10 days, things have been out of control in Jordan in terms of stem cell work. So I sent Jim the title for my talk, and again, just like what he did to Tom, he changed the title. So this is the title, and now he wants to change the title of the position since you have appointed me. So I said, well, check with Lori. Okay. So I'm gonna, during my talk, stem cell research, for some of you this would be too basic, but for some of you that would be just refreshment of your cell biology and stem cell biology. So we hear a lot about stem cells, but I think most of us hear about it in terms of controversy and all of the problems that go with therapy rather than the science of stem cell biology. Many people worldwide support stem cell research, especially human embryonic stem cell research, and they think and they believe that it is the secret cure to many, if not all, the human diseases. Many people, on the other hand, are against stem cell research, especially if it is involving destruction of human embryos. So let's start by defining what a stem cell is. A stem cell is a cell that has the ability for unlimited continuous division. So and to stay in its undifferentiated state. So we're talking about self-renewal and proliferation. It also has the ability to differentiate to many types of cells depending on its potency. So again, the characteristics that I will keep repeating are self-renewal, division in the undifferentiated state, proliferation, conversion to more differentiated state, and the hope that stem cells can regenerate damaged or dying tissue. So a lot of scientists call stem cells as plant cells. Again, they are capable of dividing, proliferating, self-renewal, and differentiation. You find, when you think about stem cells from self-renewal, and this is the scheme that goes inside your head, that a stem cell will divide to get one copy of itself and another copy of differentiated cell. But this is really not the case. A stem cell will divide either to get two copies of itself, so this is self-renewal, or differentiate into two cells under certain signaling pathway. So this is the correct scheme for the characteristics of stem cells. So we will be talking about potency, how many types of cells a stem cell can give rise to, self-renewal, and of course I will mention a little bit about the controversy about the stem cells, and I will give you my experience about stem cell work in my country, Jordan. So why is self-renewal very important? Just to keep the stem cell pool in your body. This is very important in case you have damaged tissues or wounded tissues or dying tissues. It's very important to replace whatever is dying or damaged in your body. Where are stem cells found? We have stem cells are characterized either as embryonic stem cells, and they are found in this embryo, which is 5 days old, blastocyst. It is composed of this outer layer, the trophectoderm, that will give rise to the placenta, and this clump of cells, the inner cell mass. And the human embryonic stem cells are derived from these cells. The other source is tissue stem cells, and sometimes they are called adult stem cells, although some of their sources are the fetus, baby, or throughout your life. So I will start with the source of stem cells. The first is embryonic stem cells. As I mentioned, they are found in this 5 days old embryo. It's called blastocyst. Pre-implantation, just before this embryo implants in the uterus. The trophoectoderm is removed, and these cells are taken and cultured in the cells, and the hope is that they can differentiate to any type of cells in your body. The first derivation of human embryonic stem cell line was 1998 by Thompson and colleagues, and it was derived from donated excess IVF embryos. These cells are called pluripotent, and I will mention this later when we come to potency. So again, as I mentioned, these inner cell masks are collected and then they are grown in the lab. This is how human embryonic stem cells look like. They like to grow in a colony that contains hundreds of thousands of cells. They have this obvious boundary, and these are grown on feeder cells. So they grow again as clusters or colonies. They like to cluster together, and they have this obvious boundary. And again, the hope is that these human embryonic stem cells, because they are pluripotent, they will give rise to all types of specialized cells in your body. Again, we have challenges, right, with human embryonic stem cells that you can think about. These are continuously dividing cells. So, and in order to prove that you have stem cells, when you inject them in a mouse, they have to form teratoma. So you always have to think of this when you think about therapy. Also, to control what signaling pathway you need for a type of cell you need. So the right amount of each cell type and the timing of that differentiation. So the fantasy is that human embryonic stem cells will be able to cure or to regenerate spinal cord, brain injury, no more organ donation. You have stem cells in the lab, you can induce them to make liver, pancreas, lungs, no need for donation, treatment for diabetes, myocardial infarction. The reality right now, where we are right now, worldwide we have few clinical trials. So we are not there yet. Few clinical trials worldwide. Where do we get them? Again, mostly from donated IVF embryos, just like what I explained. And these have been used for therapy, mostly for research, and to get these inner cell masks using somatic cell nuclear transfer, so that you wouldn't have the need to destroy an embryo. The other source is tissue stem cells or other stem cells, and you have them everywhere in your body. You have them on the surface of the eye, brain, neuronal stem cells, skin, breast, gut. Wherever you feel like there is a need for replacement of damaged tissues or dead tissues, you will find stem cells. Testicles, muscles, bone marrow. These cells are considered to be multipotent. So we moved from pluripotent, being able to give all types of different specialized cells in your body, to becoming multipotent, giving certain types of cells, depending on the organs where these stem cells, types of cells, depending on the organs where these stem cells are. So for example, gut stem cells will give digestive system cells. Bone marrow will give rise to hematopoietic stem cells, and so on. So you have hematopoietic stem cells, neuronal stem cells, gut stem cells, mesenchymal stem cells, and so on. The third source, which I think Soham would be mentioning in his talk, are the induced pluripotent stem cells. So these are somatic cells that reverse time. It's like the clock was reversed. These somatic cells were reprogrammed, and eventually they gave stem cells, and they behave like embryonic stem cells through reprogramming. Stem cells through reprogramming. So you culture them, and then you differentiate them, and they are excellent to do research on. So there is no need for embryos. The first report of making these induced pluripotent stem cells was 2006 by a group in Japan, Takahashi and Yamanaka, 2006. And the 4 factors that they used, eventually they discovered that you only need these 2 factors were called Yamanaka factors. I'll mention them, but I think Soham will explain them maybe more. So these were mouse-induced pluripotent stem cells. The same group in 2007 made human-induced pluripotent stem cells, the same group. Okay. But because they used retroviruses to do the reprogram, that problems that have to do with retroviruses, where they recombine with the genome, tumor suppressor genes, they really cannot be used for therapy. So you take fully differentiated somatic cell, you reprogram it through genetic engineering with these 4 factors, and you get pluripotent stem cells that you can differentiate into different types of cells. This is the method of making these pluripotent stem cells, and these are the 4 factors of 3, 4, SUMS2, KLF4, and CMEC. So again, there is no need to destroy embryos. You can take somatic stem cells and make them into human embryonic stem cells. In 2014, a Japanese group announced that they will be using these cells to create to cure eye problem or eye disease for a patient. I could not follow up. I did not find any follow-up for their trial. Like, where is it right now? The only literature is about the attempt of this work. The good thing about induced pluripotent stem cells is that you can take somatic cells from patients of neurodegeneration, Parkinson, Alzheimer, reprogram them, and then differentiate them and start to understand the pathology. And you can also try new drugs, new therapies for such diseases. So this is very important for neurodegeneration. The problem again, we are still behind with using these cells for therapy because of teratoma formation, safety, tumorigenicity, immunogenicity if you are using allogenic or heterogenic cells. Using allogenic or heterogenic cells. So again, so many problems or disadvantages for using them for therapy, but very good for research. And this table compares the different sources of stem cells, embryo, induced pluripotent or multipotent in terms of proliferation, availability, differentiation, and potency. The other category of stem cells, they are divided in terms of how many types of cells they can give. The first type of stem cells are called totipotent stem cells, and these are taken from 1 to 3 day old embryo. Each cell can give a whole embryo and extra embryonic membranes. This is how identical twins are formed. And pluripotent, just what I explained, taken from inner. Multipotent, these are the adult stem cells or cord blood cells or fetal tissue. There is another type of stem cell called unipotent stem cells, and this is found in the testes or in the ovaries, spermatogonia, and oogonia. So totipotent from 1 to 3 day old up to 8 cell stage, pluripotent, inner cell mass, and then multipotent. Another concept that I wanted to come across is that is the stem cell mesh. This is very important for neurodegeneration. I will just mention it with a clinical trial. This is the microenvironment that keeps the stem cells pluripotent, that keeps them from differentiating. So This is the microenvironment surrounding the stem cell, honing the stem cell. It regulates self-renewal and differentiation. It could be from neighboring cells, extracellular matrix, through cellular factors, or through intermediate cells. And they provide this signaling pathway that controls self-renewal and differentiation. This is very important for neurodegeneration. Okay, so moving to therapy, the base of my talk. Where are we now with stem cell research? If you go to the internet, or you will find many clinical trials. Again, it's so hard to follow up these clinical trials to get the results. They announced the initiation of that clinical trials, but for many of them, I could not get the results. But in anyhow, in order to use stem cell-based therapy, this therapy has to be long-lasting, of course. If it is it has to ameliorate symptoms and counteract disease progression. So many challenges, as I mentioned. One of them is to know which stem cell to use: human embryonic or induced pluripotent or adult stem cell. Right timing and right amount of cells. For example, studies have shown that how we prepare the neuronal stem cells, the method of grafting, and the timing of graft transplantation affects survival of these donor cells. Also, you have to consider immunogenicity or immune rejection. When you go to the literature, you will find many clinical trials that have been using embryonic stem cells, neuronal stem cells, or mesenchymal stem cells. And the hope with these clinical trials is to find the same success that physicians have found with hematopoietic stem cells. You know how successful they are with this type of stem cells, hematopoietic stem cells. But this type of therapy is 40 years maybe ahead of stem cell research. But the hope is always to reach a point where we will have the same success as hematopoietic stem cell research. And now hematopoietic stem cell research either uses bone marrow, or peripheral blood, or cord blood. In Jordan, right now we have cord blood bank, and we have stem cell bank for hematopoietic stem cells. Somehow a success story is using stem cells for blindness. There was a clinical trial in Italy for corneal disease where they used autologous limbal stem cells, and the majority of the patients had complete restoration of their cornea, but the severity of the blindness was not really cured completely, but it was enhanced. The same trial was repeated in Australia. So that's a success story. Also, macular degeneration, disease of the retina, is another success story where they use either human embryonic stem cell and they derive retinal pigments of epithelium, or from, as I mentioned in Japan, from induced pluripotent stem cell. However, there are some like failures. I don't know if you read about it. Maybe 4 years ago, 3 Florida women went for liposuction, and then the physician said, well, you know, with fat there is mesenchymal stem cells, and they had some corneal disease. One of them had macular degeneration, so they isolated these stem cells, mesenchymal stem cells, from the fat, and they injected it in their eyes. Few weeks, they started forming cartilage in their eye, and they were blind. So we have some failures because of, well, I think it is not really regulated. Heart disease is another disease where stem cells have been used, but in this case, adult bone marrow. For these patients who received stem cell injection, the scientists found better mean reduction in infarct size, perfusion, and if the heart was, or the infarct site was regenerating. Okay, what about neurodegeneration? The whole idea behind using stem cells for neurodegeneration, or the conventional idea, is that you inject stem cells into the brain of patients, and these stem cells will differentiate and be the source of new neurons. But that was not the case. So these neuronal stem cells did not really regenerate, and I'm talking about model systems, animal models, did not regenerate new neurons, but they were good. They incorporate within the neural network, and they were good to secrete neurotrophic factors, which is so important for the microenvironment of the neurons. That was very important to upregulate neuroplasticity of the neurons. That was very important to upregulate neuroplasticity and neurogeneration, and that upregulated the survival of remaining cells. So again, in animal model, these neuronal stem cells upregulated or enhanced neurogenesis in the hippocampus of Alzheimer's rates. Also, stem cells have been used for spinal cord injury. There was a company, I don't know if it is Geron, that started a stem cell clinical trial for complete spinal cord injury patients. It started the clinical trial 2010, ended in 2011 because of lack of funding, but I think 5 patients received stem. This is one of them, Tahtamouni. This patient had ALS. He received, before the injection, he could not climb the stairs, so he could not raise his leg. He received 10 injections of stem cells, and then he was able to walk through the 2.5-mile walk to defeat ALS. So his disease was not cured, but it was enhanced. Like he was able to walk at least. Not only human embryonic stem cells were used, also mesenchymal stem cells and refractory stem cells were used. Fetal-derived neural stem cells were used in different clinical trials worldwide. In Jordan, because we don't have, up till last year, we did not have any regulations for stem cells. A lot of companies based in Europe with their stem cell therapy on spinal cord patients, and we will hear all of these bad things happening to patients because there is no regulations and there is still no medical justification to use or to start such clinical trials. Cerebral palsy is another disease where umbilical cord blood has been used. 2 clinical trials, one at Duke University, another one in South Korea. Stroke, difficult disease to treat, but still there is one clinical trial that has started in UK to treat stroke patients. The problem with stem cell research is, especially with these clinics all over the world, especially where there are no regulations or privately funded clinics, is that there is when they do this stem cell therapy, there is little or no medical or scientific justification. It's really very expensive, and I think they take advantage of these desperate people. They forget, about immunogenicity and all of these things. So these are all major concerns. Stem cell research is still in its infancy. It's really a new research. In a few years, maybe 1 decade, 2 decades, I'm sure we can get to where hematopoietic stem cells is right now, but still it is too early to use it for therapy. These human embryonic stem cells, whether they are from the inner cell mass or induced, they are a great source for neurons in culture. Still, we are way behind for using them in therapy. In the States, you know, they are highly regulated. 1995, the NIH were very supportive for stem cell research, whether it is to create stem cell line or to work on stem cell lines that exist. However, because of the ethical controversy and all of that, President Clinton had his executive orders that public funding cannot be used to create new cell lines. So you can work on existing embryonic cell lines, but you cannot create it if you want to get funding from public sources. A lot of controversy around stem cells. These are just thoughts for your brain, especially with the human embryonic stem cells. When is an embryo considered a human being? Is it ethically, morally acceptable for a scientist to destroy an embryo for research? Just ideas for your brain to think about it. You can find all of these cartoons, you know, making fun of human cell research, but you know, you have to think about the science, because people only hear about scandals and bad things, but they don't really think about the science. Stem cell field is still in its infancy. It's only 2 decades old if you think about when Thomson really derived the first human embryonic stem cell line. I'm sure in a few years we will hear about all of these medical treatments using stem cell research. Many countries have regulations, the US among them. Most countries in the third world, we don't have regulations, just a set of regulations that we hope that scientists and physicians will obey by. In Jordan, it is now forbidden to create human embryonic stem cells. You cannot destroy an embryo to create human embryonic stem cells. If you want to do stem cell therapy, you have to be a certified, accredited institute. I think now in Jordan, what we are doing is cryopreservation of bone marrow, and for patients, especially young patients with cancer and things like that, we are keeping testicular tissues and ovarian tissues. My presentation will be uploaded on the website, so I'm not gonna talking about all of these regulations and ethical concerns. We can talk about it later on, and you can read about it, like how the guidelines for stem cell research in the US has come. And thank you. It depends on the clinic, and it depends on, like, if you are talking about what, cerebral or spinal cord injury, I can't remember the numbers, but the follow-up is at least 2.5 years, the follow-up. And they take, like, for that guy, it was 1 year, 10 injections. So then 1 year, he took 10 injections.
That's great.
Yes, that's straight, yes. And for the heart, straight to the impact side. And for spinal cord injury, wherever you have the injury, they will just hit that spot. And they can get some improvement below the site of injury.
Do they infuse the stem cell like getting compensation?
If it is not a genetic disease, they might. If it has a genetic defect, then you won't have like equipment. But then you have to think about all the immunogenicity and immune rejection and all of that.
So I remember about 20 years ago, our physician in town tore ligaments in his ankle. And he wanted to try stem cell therapy, and there was no place in the US where he could get it done. So he went to Sweden, and they took his fibroblasts and converted them, or they took some cells and converted them into cells that would lay down the cartilage. And he had those re-injected and rebuilt his ankle. Is that done fairly widely these days?
Yeah.
For that kind of...
Yeah. So especially with diabetic patients where they have all these fractions, is widely done. Skin is something that's really made from embryonic stem cells or other stem cells for just with skin, for example, they can make up the epidermis, the dermis, but not the hypodermis. So they do save the life, but the quality of life is not as before. I'm talking about because I have experience in Jordan. Right now, a lot of dermatologists are using stem cells and stem cell derived products for filling and wrinkles. All of these things.
To add to the success stories, and what Ning was asking, yes, actually, one of the diseases, like skin-related disease, is called epidermolysis bullosa, where the skin actually peels off in a mutation in keratinocyte in collagen. So actually, my previous lab and then this collaboration with the University of Colorado, they actually fixed those mutations and actually implanted, actually made iPS cells and using gene targeting, and then re-derived fibroblastic keratinocytes and planted on the patients, and the patients are doing pretty good.
Even
So
in
there are
Jordan,
6.
one of the success stories is for stem cell transplantations. It's amazing what they can do. The cartilage and the skin. It's one of these success stories. Rita?
So for cerebral palsy patients, there were big companies in Germany and China were desperate people were taking their children there. And they were taking stem cells they were taking blood transfusions, giving them blood transfusions of stem cells. How do these stem cells know how to go to the brain?
So how can I answer you?
And they say that they know these cells will go to the brain. But where there is
the homing signal. I don't know what they mix them with. Yeah.
And not that I know that none of
what they mix them with. Yeah.
And not that I know that none of them work.
Yeah, I think they depend on what we call the homing signal. So, for example, and that was my the whole point of me joining that committee in Jordan, that we had this physician in Jordan, infertility IVF physician in Jordan. He had this big ad in which he would take bone marrow from infertile men and inject it directly into the testes, and he claims that they would make sperms. And that was like, no. This is this is like a fairy tale. This is not happening. And yeah, it's not. A lot of these private companies, they depend on these disparate people. But, if you have a patient with cerebral or spinal cord injury, quadriplegic or something, they would do anything.
For the injections, how do they actually put the stem cells in there? Are they like in a hydrogel or a collagen matrix? Or?
I've never been in an operation. I only go and prepare them, like do the sorting, but I don't know exactly. Yeah. Thank you.